Good morning, everyone. I'm from邓肇堅Victoria Government School, Students Tem and Tech, and with my dear supervisor, Mr. Law. Today, our topic is Introduction and Application of Fuzzy Homotopy and Fuzzy Deformation Retraction. So let's get started. What is our aim and goal of this project? Is to refine that there are some objects having an uncertainty membership and it changes continuously over time. So in order to deal and describe this situation and this condition, we want to invent or create a tool called fuzzy homotopy. So how does this fuzzy homotopy deal with this specific object, or put it in another way, what properties does this fuzzy homotopy have to deal with these objects? So first, we say something about fuzzy. Fuzzy set is a set specific to deal with objects with uncertainty membership. It is a set containing elements having some degree of membership. So what does it mean by degree of membership? We know sometimes from classical set, one in this example surely belongs to this set. But however, sometimes we can't say so surely, so certainly, this one is belong to this set. So we introduce a fuzzy set, and by some grade of membership, for example, we assign the grade of membership 0.6 to the element 1. With this, we say that maybe probably the 1 probably belongs to this set, but not 100% sure. With some concrete example, for example, this one, we see from it is Hong Kong, and across the Victoria Harbour, we have some smoke here. But in this smoke may not come from Hong Kong and may be blown from the wind of mainland China. So how does this smoke classify into Hong Kong or mainland China? We may use the fuzzy set to deal with it. Another example is this. How to define the coastline in GIS? You see the sea level. This may rise in high tide and drop in low tide. So however, with GIS, you have to really define a boundary in this coastline. So again, with fuzzy set, we may probably define different degree of memberships in different positions in order to derive a strict boundary. So it is a tool deal with membership in uncertainty. And another, homotopy, how does it do so? Actually, it deals with objects continuously changing over time. It is a deformation between two curves, two functions. And one famous example is the homotopy of a coffee cup into a donut. And this homotopy can make us know more about the process of the changing and also the relations between donut and the coffee cup. However, with these two very different concepts, fuzzy and homotopy, how can we combine them together to produce a meaningful tool? This is my main question. And actually, you see homotopy different from fuzzy in the sense that it involves topological space. So in order to merge them together, you have to first introduce or create a fuzzy topological space first, and so that you can put these two ideas in the same level. Then, through some terminology, we create this fuzzy homotopy, but does it really have some real applications? If not, it is quite useless. So, in the following, I will present one important example to illustrate my point that this fuzzy homotopy actually has some real applications in our daily work. That is medical diagnosis. Well, in this case, a patient is suffering a kind of disease and receiving some medical treatment, and we want to evaluate this medical treatment by investigating some change of status of cells over time. And this actually involves homotopy. We take out 10 cells inside a set SC, and in different time we classify them into different type of cells, maybe dead cells and stable cells. We take it in this way with some 1, 2, 3, 4 here. And actually, in the time of line AM, we can plot a curve, and in another time, maybe as long we can plot another curve. And this generates a 3 curves with actually a homotopy between them. With this homotopy, we can know the process of changing, and also we probably know how well the medical treatment is. For example, 4 is the healthy cell, but actually the yellow line indicates the later time. You see that the yellow line actually does not fall on this healthy cell so much. So maybe this medical treatment is not very good, I think. However, with this homotopy, does it enough to say something about the medical treatment? We only know the process, and actually we can't say the medical treatment is, we don't know the detail of the medical treatment. How does it influence the cells? So I here introduce a fuzzy concept, that is, introduce a degree of membership into each cell. Maybe C1, maybe C1 assigned 0.6, then the degree of this 0.6 degree of membership may mean the predicted stability of cell. That means with 0.6, it may vary in a medium level, that over time it will gently change into another cell and gently change into another. But with maybe 1, the membership, degree of membership be 1, it may concretely stay in the position of the cell without changing its status. By doing so, we can investigate whether this predicted stability match with the overall data we get. Since the overall data we get, maybe C1 actually fluctuates a lot, but we say the predicted stability only 0.1. So we can actually adjust by looking at the data to improve our stability. With this improved stability, we can actually know better the dynamics of the cells, so that you know what effects do the medical treatment have on these cells. Another important application is maybe you can predict whether the cancer cell will invade on other cells. For example, cancer cell represented by 2, then when the curves change, if much points fall on this level 2, that means many cancer cells, this large number of cancer cells may not be coped with the medical treatment we introduce. So it may expand and invade other cells. So we can actually do so by investigate in this way through introducing fuzzy and homotopy. Well, when saying cancer, it is worthwhile to say that invasion of cancer cells on other cells is actually a fuzzy deformatory retraction of the set containing the cells. Since other cells may be changed to the cancer cells, so that actually geometrically it is a retraction. So with this example, in conclusion, I have to show that the fuzzy and homotopy actually can merge together to form at least it is fuzzy homotopy, and through daily examples and applications, we show that it is actually useful in daily sense. There are objects to be dealt with this fuzzy homotopy. For example, medical diagnosis. Another thing is about homotopy, which involves a geometrical meaning actually. So in our paper, I show that actually a vertex of a fuzzy topological cone is actually a fuzzy deformation retract of this cone. And a more important point is that since this is success, actually maybe the algebraic topology can be further developed by introducing this fuzzy concept. Yes, that's all. Thank you.